Hi everyone, my name is Sébastien Blanc and it's an honor for me to present you event-driven architecture with Kubernetes, Kafka and Quarkus. We have 30 minutes, it's really short, so I will give you a few tips and explain you why it is important to move to this modern kind of architecture. Again, I'm Sébastien Blanc, I'm the Director of Developer Experience of Red Hat MEA, and without waiting, let's move to some slides. So that is the title, you already know about it. So let's move to this statement. That is something that we often hear. Code is eating the world. Which is true. Everything is going digital, everything is going online, and it will be more and more. So this statement is correct. But code is not the most important thing. There's something more important than code. And that is data. Data is king. All the data produced by your users, clients, suppliers, your business is crucial. It's your most important asset. Okay? And so, the way how you manage this data is really important. Let's take a step back and see how data was managed a few years ago. So here we got the classic architecture. I got my monolith app, and I have a client, a web app, and it makes a request, and the monolith app do a request to the database to retrieve some data. All the data is stored in the database, and there's just one single point of entry. Not that many events produced here. Well, they are quite simple. Then we move to a more distributed architecture, also because we started to move our workloads in the cloud. But from one monolith, we went to a multitude of services, all handling their own concerns, their own feature. And in the beginning, they were still consuming all the data from the same database, which was not a good practice. Luckily, quickly, we could see that microservices started to use their own databases, okay? And you start to see a lot of components here. And just keep in mind, each interaction of here, if I do a get, if my microservice called this microservice that retrieves some data, well, what happens? It produces events. All kind of different events of different natures. And all these events are really important because these events contains your data. Okay? But bad things can happen. We are in computer science, in networking. Things can go wrong. Your microservice can go down, your network can go down, failures happen. And we will see how to make sure your system is the most stable possible right after this. But still, failures will happen and you have to deal with them. Okay? Imagine here this service fail, or there's an issue with your workload here. Well, this client will not be able to consume any of the events here. And maybe these events contain some crucial data that can bring some business for you. So, in the end, the way how events are distributed all around your infrastructure is not the best way to go. Events should be in the center of your infrastructure. In the center, but across your whole infrastructure, centralized in a single place and where your events will be resilient. Okay, let me skip this slide. It was just to tell you that different components can consume and produce events. We will come back on that later. I just want to come back on this idea of having a transverse component where all your events will be stored. Okay, well, they will be recorded. And every microservice can produce events and put them in this component. Imagine that as a river of data, a stream of data. Every database, every microservice can produce events, but can also consume these events. Okay? By going this way, this is the central piece of going to an event-driven architecture. Okay? And to do this, well, there's one component, one solution that exists, and I would like to introduce you to Kafka. Kafka is de facto solution for data streams to manage your events, your records of data. Kafka is built for the cloud. Kafka can scale. Big organizations are using Kafka to handle millions of events per second. And it just works. Okay? Kafka is resilient. Kafka is clustered. If you have one Kafka cluster that goes down, that's not a problem because you will always have replication of your events, of your data records. Okay? In 30 minutes, I cannot give you a whole course about Kafka, how Kafka works, but basically there is a broker and there are producers that can produce data and there are consumers. Okay? And these can scale as needed, and Kafka will make sure of the order of your events. It will make it possible for any consumer to replay a series of events. Okay, it makes it possible to combine different events to process them. You can do crazy things with Kafka. But before we see how you can install Kafka yourself in the cloud, there's one thing we have to make sure. Let's go back to this picture. You can see here there are a lot of moving parts, a lot of components, microservices, which are workloads, databases, and all these components needs to be packaged, needs to be deployed to production. And once they are in production, they need to be monitored. They need to scale up, maybe scale down if they are not used. They have to deal with networking, not having conflicting ports. They have to be able to report metrics. They need to be able to heal themselves if anything goes wrong. You could do that yourself, but really, I would not recommend to do that. And there are different solutions to handle that, but nowadays, the most common solution to handle your workloads, and I'm sure most of you already know what I will be talking about, is Kubernetes. Kubernetes is the orchestrator for your workloads, the orchestrator for your containers, because in the end, you will take your workload, so your workload is your Java application that you put in a container, and this container, you deploy it to a Kubernetes cluster. And you say to Kubernetes, I want 3 instances of this workload, and Kubernetes makes sure to deploy these workloads into different nodes if needed. It will make sure that if your workload is down because there's some memory issue, to stop it, to restart it. It will make sure to expose the services to the outside, dealing with all the craziness that you can have with networking. It's all done with Kubernetes. Like Kafka, I could talk you the whole day about Kubernetes, but we have only, well, I'm checking the time here, only 20 minutes left, okay? So what I really want to do still, before we dive into Kafka, is to give you a power demo to show you how Kubernetes can help you to make your workloads resilient, okay? So let me go here to my cluster, which should be somewhere. Oh, it's here. It was just it was just here. So this is a Kubernetes cluster. It's running here on the public cloud on Amazon, and I'm using OpenShift. OpenShift is Kubernetes. Think as Kubernetes for the enterprise. OpenShift is built, maintained by Red Hat, so you have whole power of Kubernetes and also the whole power of Red Hat. Support, community, everything. Okay? So, one thing that I want to show you is a deployment. What is a deployment? A deployment is a construct, an entity that makes you possible to describe how a workload looks like in your cluster. Okay, and here I do that from the console. Here you can do that from the console, but most of the time you will do that from your command line or with some automated tool like Argo CD or whatever. Anyway, here I create a deployment, and important thing to check for now is the replicas. Here I say 3. That means I want to have 3 replicas of my workload. And which workload would that be? Well, that is defined by my container. Okay, and here I specified which image I want to use for my container. In this case, I just want to use an example, a sample project from OpenShift called Hello OpenShift. Okay, and I expose that on port 8080, no problem. And I just push here create, and here we can see my deployment. It's scaled to 0 now, but it should scale really fastly to 3. Now I have 3 instances of my workload, and these are represented by pods. Okay, pods is the shell around my container. And if you take a look here, you can see 3 pods. Okay, I just make sure that my recording is, yes, okay. Sorry for that. I just wanted to make sure that I was just recording, because you believe me, I just did the whole talk just before and I forgot to press the record button. Anyway, there we go. I got here 3 pods, and as I told you, we have 3 replicas, and the cluster will always make sure that we have 3 replicas. So for instance, if something goes wrong, and I simulate that here by deleting my pod. Okay, I delete my pod. It's terminating, and right after here you can see that a new container is being created. Okay, the same thing here. If I go here to my deployment and I go for 4, let me go, it will just kill to 4 pods. Okay, this is the administration view. Maybe if you are more a developer, you will love our developers view, which is more visual. So here I have just 1 deployment, but imagine if you have a lot of workloads, it's all represented here. And if you click here, you can have an overview of how many pods are running. Okay, some metrics here around. And from here, I can also scale down. Okay, that's all I want to show you because I don't have more time than this. I want to come back on the Kafka topic, our river of stream. How are we going to handle this in our Kubernetes cluster? Well, good news, Kafka and Kubernetes are friends. They work really well together. And installing Kafka inside your Kubernetes cluster is really, really easy. Why is that? Because we have this concept of operators. Operators, think as an operator as a component that automates a lot of manual steps, like installing a database, installing your service mesh. The operators does all the manual steps for you. And there is an operator for Kafka. So if I go here in my operator app, which is available in OpenShift, I look for Kafka. I can see here different operators. I got here the Red Hat Integration AMQ Streams, which is the product version of Kafka. And I also get here Streamz, which is the upstream version. We always have an upstream version and a product version. I have installed here the upstream version already. But again, it's just a matter of saying, here it's uninstalled, but in my case, if it was the first time, it's just a matter of clicking install and I get the operator available. Okay, I got the operator available here. I click on it. And look, what is really interesting here is the provided APIs. That tells me everything that this operator can do for me. And the really first one that it's proposed to me is the Kafka API. And that will just create, well, I say just, but a lot of is happening here. But here I just click one button and it creates a Kafka cluster for me with 3 replicas, etc. Okay, I can tweak that if I want, but I can stay with the defaults. And here I say create. Okay, and let's take a look at our workloads here. And let me take a look here. And here we can see, well, here we can see our pods from before. We can see 3 Zookeepers clusters. Kafka works with Zookeeper. Zookeeper will make sure your data, your events will be replicated and resilient. So if something goes bad with one of your Kafka cluster, you will always have replication. That is handled by Zookeeper. So Zookeeper is running, and now he starts to deploy my Kafka cluster. Okay, it's already running, container is almost ready. But look, I clicked on the button maybe 1 minute ago or 2 minutes ago, and look, I have almost my Kafka cluster running. There it is, it's running. Now I can send millions of events to this cluster. It will just be able to handle them. And you saw how easy it was to handle. Okay, if I go here to my operator, quick look at the other things that I can make. One interesting one is the topic, because Kafka works with consumers, producers, and producers, they produce events, records on a Kafka topic. Think as a topic like in a forum, you have different topics. Well, it's the same. You have different streams of different topics that contain different streams. Okay, you could use just one topic, but a good way to go is to have a multitude of topics. Now that we have our cluster in place, we have our Kafka in place, we need to have our workloads. So our applications. And if you start from scratch, you should consider choosing the right Java stack to create your cloud native application. And the way to go today is called Quarkus. Quarkus is a Java stack from the future, except it's already available today. Quarkus is made for the cloud. It's targeted for the cloud. It will make for you super small, super fast workloads that you can easily package into containers and deploy into your container. It has a lot of different extensions targeted again for the cloud, like metrics, health, security, and data streams to communicate, for instance, with a Kafka cluster. And we will see that in a few seconds. Before that, I want to give you a power demo of Quarkus. And after that, we will see how we can use Quarkus together with Kafka. Okay, so let me go to my IDE here. I'm using Visual Studio Code because it's really light and it has really good support for Quarkus. Okay, and we will create a new application from scratch. So I say here I want to generate a new Quarkus project. I'm using Maven. This is the name of my project ID. Where that forum, yeah, that was when I did recording before. Live test, let's call it live test, for instance. It's a snapshot. That is my resource that I want to generate. Okay, and let me generate that here, and it will open a new window for me, like here. And again, like Kafka, like Kubernetes, I cannot show you everything about Quarkus, but believe me, you really have to try it. It's really awesome. It has created for me a new project, and if you are a Java developer, you probably recognize here a Maven structure, okay? And it has also created for me a REST endpoint to start with, okay? And I have already an application running on port 8080. So what I will do here, I will just specify another port just to make sure we don't have any conflicts. 8082, for instance. There we go. And now I can start my application. I open a terminal here, and what I will do, I will start it in dev mode. So oh, I made a typo, sorry. Dev mode is a special mode for developers when you are locally developing your app. It runs your app, but it listens to any changes that you could make, okay? So if I open here a new terminal and I curl my endpoint here, curl localhost like 8080/rest easy/hello. I should have hello here. What did I do? Oh, wrong port, sorry. 8082, there we go. I say hello and hello MEA, for instance, okay, and here I do again, and here I get hello MEA, and I can even go crazier. I can even add a new method if I want, and I put that to on the path of yeah, there we go, sorry, path/fr, for instance, and I call this method bonjour, and here I say bonjour MEA, okay, I save that, I clear this, and now I run it again, and I do hello/fr, and I say bonjour MEA. So that is just a quick demo to show you the developer's joy. I can add methods, I can add classes, I can add dependencies, I can change the configuration. I never need to restart my app. And once I'm done, I will make a jar or even a native, because you can make a native binary with Quarkus as well. And it will be really small. It won't consume a lot of memory. And it will be easy to put that into a container and to deploy that. Okay, let's go back to the topic. As I told you, Quarkus is also perfectly fit to work with your river of stream of data, to work with your Kafka cluster. And for this, I got a small example here. I got two applications, okay? Let me go here. I got a first application. Okay, let me go here quickly. And here it's just a really silly example, but it's just to make the point. I got a list of numbers, okay? And I got here a reactive construct. Again, I don't have time to explain everything around reactive, but keep in mind reactive is a programming paradigm that is made to work with streams of data. And in the case of Kafka, it makes perfectly sense, okay? Here I say, what I say, every second, pick a random number from here, from this list, do some processing around it, and send it to a Kafka topic that is called Numen, okay? And look how easy it is to just send this to a Kafka topic. I just have to annotate this with an annotation called outgoing, and I specify the name of the topic, okay? Of course, I need to provide some configuration, but look, here there's the outgoing part. I just have 3 lines of configuration, specifying that I want to send it to Kafka, the name of the topic, and the way how I want the data, the event to be serialized. In this case, I just want it to be serialized to a string, okay? So that is for producing data on my river of data. And then I got another application, which is listening, look here, it's listening to the same topic. So every random number that is put on the topic, this application here, by just putting incoming, it will be capable of consuming these events. And what I do here, I take this event, I turn that again back to an object. In this case, it's an agent object. I do some data transformation with that. Here in this case, I just pick pick up a random enum status here, and I append it to my object that I just retrieved. And I return this. And look, I just did return, and here I specified an outgoing annotation. And by doing this, I will produce data on another topic, and this time it's called agent status. So I have got two topics here, okay? And again, I got some configuration for my incoming to consume the data and to produce some data. Really simple. And here for now, I'm showing you this demo locally. So I have a Kafka cluster running locally with Docker Compose. It's really easy to do. I could do it in the cloud because you saw we already have our Kafka cluster running, but it's easier for me here to demo this locally. So to come back here, it sends back, so it retrieves some data from Numen, it does some data transformation and put it again back on another topic called agent status. And let's go back to our first application here. And here I have a resource class where I will consume the data from this topic. And this time, look how I do it. I specify here a stream. So multi is a stream, represents a stream of data. And I say, well, this stream of data, it comes from a channel. In this case, it will be a Kafka topic called agent status. That is all I have to do to consume data from this topic. And here I have a REST endpoint, so it's a GET method. And here every time I receive an event, I do some transformation and I send it to the front end. And take a look at here what I do. What do I send back? I send back a server sent event because we are speaking about events. It's like pushing data from the server to a front end or to another service. Okay, so what I'm going to do here is to run my app. Well, my app is already running, okay, and I will just call this endpoint here status, okay. And what should happen if I do curl local host 8080/status, here you see I get, oh yeah, it went really fast in the beginning because I understand what happened. It went really fast in the beginning because a lot of events were already produced. So he sent me all the events that he had already recorded, and now you can see every second I receive a new event. And remember what happens is this application that picks a random number, do some transformation, put it on a topic. I have this other application that reads, that consumes this event, that does also some data transformation and send it back on another topic. And this app can read this topic and finally sends this data back here. In this case, is to the client. I'm doing this with a curl, but if I open that here in the browser, for instance, I go here for localhost 8080/status, I should see again also, there we go. Maybe with Chrome, that should work. Let me see if it works with Chrome. Well, I shouldn't have shown you that in the browser, but let me see here. Here's still working. But in the browser it should work. You will never do that. You will use a JavaScript library to consume server-side events, okay? Because it has no way to show this raw data. But I think I made a point here. I got a few seconds left. Again, really important. Have a solid infrastructure by using Kubernetes OpenShift. Put the events in the center of your architecture by using Kafka. And you saw how easy it is. Build solid cloud-native application using Quarkus because it has support and it's so easy to use data streams as you can see here. Okay, so I go back to the big screen. I would like to thank you a lot and see you around and have a nice day. Bye bye.